Let's talk about areas for trapezoids. What do you remember from a geometry class about trapezoid areas? We usually had something like this, and we called this length base 1, we called this length base 2, and we called this the height, and the area was base 1 plus base 2 divided by 2 times the height. And another way to think of that is we're averaging base 1 and base 2. That's what base 1 plus base 2 over 2 is. So we're kind of saying that this is like a rectangle whose base length is the average of the two base lengths. So let's write that down. So whose length is the average of base 1 with base 2, and the height is h. Here in calculus class, we're going to draw our trapezoids differently. Let's say we had a function that goes from like 6 to 12, and it goes up, over diagonally, and down. Let's say this is 3,000, and this peak here is at 5,000. Go ahead and label this. We want the area of that shape. Go ahead and label it according to base 1, base 2, and height, or maybe different letters. Okay, so it's basically this shape turns 90 degrees. So this length is base 1, this length is base 2. And instead of height being measured vertically here, we can say it's horizontal. That we've got the two parallel sides. That's the important part. Two parallel sides. Here they were horizontal, here they're vertical. And the height is the distance between those two parallel sides. But we could also call it delta x here. So what's the area? Well, it still is base 1 plus base 2 over 2 times height. But we can rewrite that now. Base 1 is 3,000. Base 2 is 5,000 over 2, and the height is 12 minus 6. That's delta x. So there's a few trapezoid problems in the homework. You can treat them by drawing a little line here. You can treat them as a rectangle. I know it kind of looks like a square, but it's a rectangle here, plus a triangle. But it's easier and leads better into later chapters to think of them as a trapezoid. Let's try our upper bound and lower bound procedures. So we've got the same thing as before. Here's 3,000, here's 5,000. In the long run, you might actually want to draw your upper and lower bound on the original figure. I'm just doing it separately to hopefully make it more clear. So what's a quick lower bound? Well, a really quick lower bound is 0, right? I better get a positive answer from this. A better lower bound would be a height of 3,000 and a width of 6 minus 12. Oh, sorry, 12 minus 6. So that's my lower bound. How about my upper bound? It would be a box as tall as the tallest part of the whole function. So that would be a height of 5,000 times a delta x, or a width of 12 minus 6. And then how about a guess? It would be halfway between those two. I could take the average of those two, or I could say it's just the average of the 3,000 and the 5,000. And do you think that guess is going to be, so remember, the guess is actually a box, but the most important part of the guess is how high it is. Do you think that guess is going to be a little high, a little low, maybe you're spot on? Depends on whether we think we're good guessers or not and the geometry of the situation. All right, next we'll start doing some more interesting things, curves.